Welcome to the Deep Dive, your shortcut to being well informed. Technology, especially in industrial systems, it just moved so fast.
It really does. Keeping up feels like a constant race.
Yeah, like a full-time job almost. But imagine having powerful open source tools that make really complex automation more, well, manageable, even accessible.
That's a great way to put it, and it's exactly what we're digging into today.
Exactly. Our focus is Eclipse 4diac. It's an open source setup for distributed industrial control systems, and it's built on the IEC 61499 standard.
Which is a really important detail, that standard.
Right. So our mission today for you listening is to cut through the jargon, really get what 4diac is, how its bits work together, and then zoom right in on 4diac Forte.
Forte is, a really crucial piece.
Definitely. We want to pull out the key stuff so you can quickly see why it matters and what it can actually do.
Sounds good.
So expect a good chat about its core ideas, the tech underneath, how compatible it is, and we'll keep it engaging. Let's jump in.
All right. So first off, Eclipse 4diac.
Yeah.
You really need to grasp that it's this open source infrastructure, right?
Yeah.
Specifically for distributed industrial control.
Distributed being the key word there.
Absolutely. And it's grounded in that IEC 61499 standard we mentioned.
Yeah.
For anyone not deep in the weeds, think of 61499 as a sort of modern blueprint.
Okay.
It's about component-based, event-driven programming.
Mm-hmm.
Makes control systems naturally distributed, much more flexible than, the old sequential ways.
And this didn't just pop up overnight, did it? I read that 4diac started out supporting research, but also, importantly, industrial use.
Correct. It was founded for both.
Yeah.
And it's definitely matured over time. New versions, better features for modeling these distributed setups.
I saw they put a special focus on performance for the runtime system. That seems critical for industry.
Oh, absolutely paramount. Milliseconds matter. And when you look bigger picture, 4diac's become this really solid base for, next-gen automation research.
And because it's built on open standards.
Exactly. That's the game changer. It really fosters collaboration, lets more people adopt it across different fields. You're not locked into one vendor.
Makes sense. So the whole 4diac framework, it's not just one thing. It's got parts.
Right. It's a suite, really. You've got the 4diac IDE, that's your integrated development environment, where you design things.
Just get the design tool.
Then 4diac Forte, that's the runtime environment, kind of the engine, the beating heart.
Got it. Forte runs the show.
Then 4diac Lib, the function block library. Think reusable code chunks.
Like building blocks?
Precisely. And finally, 4diac SYS, which gives you example projects, helps you get going quicker.
Okay. IDE, Forte, Lib, SYS, all vital. But you said Forte is the real engine. Let's unpack that.
Yeah, let's focus on Forte.
Yeah.
So when we talk about 4diac Forte, we're talking specifically about that core real-time engine, an IEC 61499 runtime environment.
Real-time being key for industrial stuff.
Absolutely. It's purpose-built for those dynamic, time-sensitive operations. It has to react instantly to events happening out there on the factory floor.
And technically, I saw it's a small, portable runtime written in C++ var.
Yep, C++ art.
Yeah.
And targeted specifically at small embedded controllers. Think 16-bit, 32-bit systems.
That small footprint and portability must be huge advantages, right? For putting it on different kinds of hardware.
Definitely. And a standout feature that really leverages that is its support for online reconfiguration.
Online reconfiguration. So you can change things while it's running.
Exactly. Think about it. Instead of shutting down a whole production line just to tweak something.
Which costs a fortune.
Right. You can reconfigure it on the fly. Minimal downtime, keeps things running. Plus, it executes all the IEC 61499 function block types in real time.
And it handles the data side well. I noted it supports all those IEC 611313 data types, elementary ones, structures, arrays.
Yes, it's fluent in industrial data. Handles the complexity you find in real factory settings.
Okay. And scalable, too.
Indeed. Its architecture is scalable, so ROTE can adapt, from simple tasks up to really complex interconnected systems.
And the applications themselves, they're built from different kinds of these function blocks. BFBs, CFBs?
That's right. Basic function blocks, BFBs, composite function blocks, CFBs, service interface function blocks, SIFBs, adapters, even sub-applications.
Like Lego bricks for code?
That's a perfect analogy. Each block is a self-contained, reusable piece of logic. Controlling a motor, reading a sensor, whatever, it makes building and changing systems much more efficient.
Something I found fascinating in the Forte docs was how it handles connections between blocks. It uses automatic and safe castings.
Ah, yes, that's a subtle but really important point.
It seems critical for safety, right? Like preventing errors if you connect, say, an integer output to a real number input.
Precisely. In traditional systems, a mismatch like that could cause, well, anything from weird behavior to a serious failure. Forte's automatic safe casting, like your INT to real example, just handles it, prevents those headaches, ensures the system's robust.
So better data handling built in, and that extends to communication too, through these communication layers.
Correct. That layered approach makes it super adaptable to different industrial networks. Ethernet, Modbus, whatever you need.
Speaking of adaptable, the range of operating systems R4TE supports is just wow.
It's pretty extensive, isn't it?
Yeah. From tiny real-time systems like Eclipse 4diac, FreeTOS, Zephyr, which you need for super fast sensor stuff,
Right, the embedded end.
all the way up to industrial Linux and Windows on more powerful controllers. It seems like it can run almost anywhere.
And that huge list, it isn't just for show. It directly tackles that old problem of vendor lock-in.
Ah, good point. You can pick the best hardware for the job, not just the brand that forces your software choice.
Exactly. It frees up system design, potentially cuts costs.
Mhm.
And the communication support mirrors this standard Ethernet, sure, but also PowerLink, Modbus TCP, MQTT for IoT,
MQTT is huge now.
and PCUA for talking to enterprise systems. It connects across pretty much any industrial network you'll find.
And it's not just theoretical. It runs on actual hardware people use.
Yeah.
BeagleBone Black, Raspberry Pi.
Familiar names, yeah. But also more specialized industrial boards, DigiConnect, Embrick, even Lego Mindstorm's EV3 for, educational or prototyping setups.
So you can actually get a board and start playing with it easily.
Definitely. Which brings us to the really direct industrial relevance, the PLCs it works with.
Right, the programmable logic controllers, the workhorses.
It integrates with controllers from Bachmann, ICOM, Microcontrol, Phoenix Contact, PLC Next, Wago, lots of big names.
This isn't just for labs or hobbyists. It's ready for real factory floor deployment.
Absolutely. It's a robust tool for actual industrial control.
Okay, so let's boil this down for you, the listener. All this flexibility, OS, communication, hardware, PLCs, makes 4diac Forte incredibly powerful and practical.
Whether you're dealing with tiny embedded sensors or big PLC systems, it offers a standardized way to handle distributed control.
It fits into lots of different places.
Right. Now, beyond the code itself, there's the community aspect. The Eclipse 4diac project is quite active.
How do they engage?
Well, they share results, future plans. They run events. Like, there's a 4 days of Eclipse 4diac Winter School coming up in 2025.
Oh, cool. Like a deep dive training.
Seems like it. They also have regular virtual community meetings and a whole series of workshops going way back to 2010. That community is a big plus. Collaboration, help, shared knowledge.
And you can get involved, contribute back.
Yes, there are clear ways to support the project or even contribute code or documentation. It's not a closed shop.
That's good to hear. And documentation is key for open source.
Crucial. And they have comprehensive docs available. Getting started guides, explaining IEC 61499 itself, understanding the 4diac framework.
Tutorials too.
Yep, using Eclipse 4diac guides with step-by-step tutorials, installation help, IDE examples, FAQs.
Yeah.
The usual helpful stuff.
And for the real tech heads.
There are detailed sections too. I/O configurations, specifics on communication protocols, even guides on developing for Forte or the ID itself if you want to extend it.
Okay, so plenty of resources there.
Definitely.
All right, so let's try and wrap this up. We've seen Eclipse 4diac, and especially its runtime engine 4diac 4TE stand out. It's open source, it's real-time capable, flexible, incredibly compatible.
All built on that IEC 61499 standard.
Right. It really feels like a practical path towards, next generation industrial automation.
It does. And that leads to maybe a bigger thought to leave folks with.
Go for it.
Well, think about how these open source community projects like 4diac, focusing on open standards and broad compatibility, how do they fundamentally change things?
Change things how?
By democratizing access, making these advanced automation technologies available not just to huge companies, but maybe smaller players, researchers.
Making cutting-edge control more accessible globally.
Exactly. How might tools like this accelerate innovation? Are things like 4diac the hidden foundations enabling those smart factories we keep hearing about? Something to ponder.